Hi, Angie back here. So hopefully you're getting used to the whole printing it off and watching the video. I'll give you a little survey here so you can let me know how you like it. Um, so we're still talking about functions and we will be for the remainder of Chapter 7. And what we want to do now is talk about domain and range. So I hit on this just a little bit in 7.1, so we'll just kind of follow up. So domain and range, they're both sets, which is a pretty important part of the definition. So sets in math have special notations that go along with them. Okay, so domain is the set of all x values. Okay, are the inputs. Okay. And they also might be called the independent variable. Okay, so, and it doesn't have to be an x. It could be a t, it could be an s, it could be any letter you want, but just kind of as a rule we use x's and y's because that's what we're used to graphing in. Okay, so don't worry, I'm going to talk about the different notations for sets down below, okay, in case you skipped over the 7.1 video. Okay, so range is the set of all y values, exactly. And the y values are the outputs, and it's also, right, the dependent variable. Y depends on x. Okay. So when we're writing these sets, we need to pay attention to whether the elements are discrete, and what that means is individual, so individual values or dots, or a continuous set of numbers. Depending on which one of these we have, it will determine the notation we'll use. Okay? So discrete means individual points you can look at. Continuous means a graph that's connected. All right, so let's go ahead and practice. And we're going to have to put some dots here in this second one that I have. So here I have a graph. In case you're wondering, it's the graph of a square root function with some negative signs involved. And we're just going to look at the picture to determine what our domain and our range are. So it's a nice continuous graph. It's going to go on forever this way. It does stop here. So I'll go ahead and put a big solid dot there so you know it stops. So the domain, when I have a continuous set, I'm going to use that interval notation that I talked about in 7.1. So for interval notation, you put the smallest number in your set first, a comma, and then the largest number in your set. So smallest number, let's see if I have an extra little piece of paper here. So smallest value, this is the syntax for interval notation. Smallest value, comma, largest value, and then we use a parenthesis to indicate not included. So this is a less than or greater than symbol. The largest, okay, and then if there's a bracket on either side, that means is included. So less than or equal to or a greater than or equal to, right? If you have either one of those, you put a bracket on that number, but if you just have a less than or a greater than, it gets a parenthesis. Okay, but it's always the smallest, meaning furthest to the left, to the largest. And in case you can't understand what I've been saying, this is interval notation. Okay. All right, so let's go ahead and practice our interval notation for that first function. So the x's, so the smallest, I'm going to look furthest to the left. So my function goes on forever off toward, right, negative forever. And in math, we call that negative infinity. Infinities always get parentheses, and then a comma, and then the largest x value in my set. So it doesn't go past 1, 2, 3. So the largest number is 3, and it does include 3. I've got a big solid dot there. If I had an open circle at my 3, I'd put a parenthesis on the 3. But I have a closed circle, so I'll go ahead and do that. Okay, now the range. So a lot of times what you can do, right, if you're looking for y values, is you can hold your pen kind of horizontally, and we're just sliding up. Where do I have y values? Nope, not yet, not yet, not yet, not yet. Once I get to y equals 0, I start having y values, and I keep having y values, right? I keep intersecting my graph from 0 on. So 0 is the smallest number. It's included, so a bracket, comma, and right, it goes on forever up, so infinity and then a parenthesis. Okay. Oh, I was meant to write it down here. That's okay. Okay, I forgot to put my dots in, so let me get a black marker and we'll go ahead and grab some dots on there if you want to follow along. Where shall we put them? How about -3, 1? How about 0, 2? How about -2, -3, and 3, 1? Okay. So I have 4 dots on there if you want to pause and get yours transferred over. I didn't get a chance to do that before I printed. Okay. So I have discrete points this time. It's not everything in between x equals -3 and x equals +3. It's just these 4 distinct x values. Okay. So it's a set, so we use set braces to tell everybody who sees it, hey everybody, this is a set. Okay. So what x values do we have, right, for our points? Well, I have an x equals -3 value. I have an x equals -2 value. I have an x equals 0. And I have an x equals 3. Okay, so those are my 4 x values. And then my range is my y value. So again, curly Q brace says it's a set. And the y values I have, let's see, a -3. I have a 1. And I have a 2. And that's it. Okay. So when it's a continuous graph, we use interval notation. If it's discrete points, we just list them and have the curly Q braces. Okay. So I'll go ahead, since I put my other one up top. So for this graph, it doesn't have the big old dot, so you can have that mean it goes on forever. So the x values, yep. So in interval notation, -infinity to infinity, right? This is the interval notation to write all real numbers, which really is everything we have up until we get to section 10.8. Yep, that's the other way, the big old capital R with the 2 lines. I do not care which way you write it on a test, unless I ask specifically for interval notation, in which case this is it. The range, right? So again, it's going off in both directions, up and down, so the range is also all real numbers. Okay, last one. Picking out the domain and range. If you haven't tried one on your own yet, go ahead and hit pause and give it a shot. So the domain, every x value gets hit eventually, so -infinity to infinity. My range, however, right, I don't have any graph down here for these y values. I don't start getting to my graph until I get up to y equals 3. So my range only starts at 3, but then it goes on forever. All right, so that's domain and range. So let's go ahead and look at what happens when our function is given as an equation instead of a graph. Okay, so there are only 2 types of equations that have domain restrictions. That's pretty important, because if you don't have one of these 2 types, your domain is all real numbers. So the 2 types are rational functions. So rational function, what we mean by that, right? Rational is just the fancy math word for fraction. So 1 over x minus 3. And we restrict the domain because there's just a certain thing we're not allowed to do with fractions. What is that? What are we not allowed to do with fractions? Right, divide by 0. So on this one, be careful. It doesn't mean x can't be 0. 0 is perfectly fine for x. What value of x causes trouble for this function? Right, x can't be 3. It could be anything else, just not the number 3. So this has a restriction. So the domain would be, how about this? I'm going to use set builder this time. Set of all x's such that x is not equal to 3. So anything else is fine, just not that. And then the other type that has an issue is a radical function. And not all radical functions, but some. And I'll talk more about this in Chapter 10. Okay. So an example, though, so you know what they look like. G of x equals the square root of x plus 2. Okay. So the reason why this has a restriction is we only take square roots of numbers that are 0 or bigger. We don't take square roots of negative numbers. Okay. So this domain, and again, I think we talk more about this in Chapter 10, but in case you're wondering, if you want to try to make it make sense, this domain would start at -2 and go towards infinity. Okay. So if your function is anything else, right? If your function does not have a square root or a fraction, the domain is all real numbers. Okay. So what are those notations? Yep. So an interval, it looks like this. Or we use the big old capital R with 2 lines, or we write the words all real numbers. Okay, so let's practice. So notice I'm not doing ranges for these functions when they're given as equations, because really we need the picture. Until we get more comfortable with knowing kind of what the graphs look like, we don't have a way to come up with the range without a picture. So f of x equals 2x cubed minus 3x. What's the domain? Do I have so here's what you have to ask yourself. Do we have a fraction? Nope. Do I have a square root sign? Nope. So the answer, the domain, is all real numbers. Just that. Okay. How about 2? F of x equals 6 over x plus 8. Do I have a fraction? I do. Okay, so for fractions, for rational functions, what do we have to be careful of? Can't divide by 0. So what makes this denominator 0? -8. So in set builder, we'd write this, so set bracket x's such that x is not -8. Okay, I hear somebody out there asking, at least in their head, how would I do that in interval notation? Because I really like that, Angela, and my math lab really wants me to. Okay, here's how it looks. So if I'm going to describe this set of real numbers, I'm going to have a little graph here so you can see it, that has everything except for that value right there. So I'll use an open circle to say everything but that. Oh gosh, if only I would have chosen something other than 8. This is going to look weird. You ready for it? Okay, so this is the other notation. So it starts, right, the x values start at -infinity. And they go all the way up to -8, but they don't include -8. So I'll put a parenthesis on it. And then, so we'll use the union symbol to say, and this next part, we start again at -8 and go on forever to positive infinity. Okay, so that's how you can write a set that excludes only one number in interval notation. -infinity up until that number, and then parentheses, and start again. Okay, g of x equals, remember that these symbols are absolute value of 6x minus 3. Do I have a fraction? Do I have a square root? That means my domain is exactly all real numbers. And lastly, g of x equals 9. Is that a function? Doesn't have an x in it. It's a function, right? It's just a constant one. Doesn't matter what you put in for x, 9 comes out. Okay, what's the domain? I promise on a multiple guess test, 9 would be one of the options. Never ask for a multiple guess in math. It's too easy to make things that look reasonable but are wrong. Domain, do I have a fraction? No. Do I have a square root? No, therefore my domain is all real numbers, all still believed. Okay, so to find the range for functions when they're given as equations, lastly, right, I've talked about this, we'll have to have a graph. Okay, we'll have to know how to come up with the graph. Okay, so last thing in section 2 is something called piecewise defined functions. Okay, and the reason they're called piecewise defined is we have different definitions for different pieces of the x values. Okay, so we kind of chunk the x-axis, and for different chunks we have a different definition to give the y part. Okay. So here's an example. Here's what it looks like. So you have your function name out here. By the way, f is called the function name, just the left letter. So f of x equals, and then we do kind of like a set brace, but it's just the 1. So the definition for x to get our y's, right, the definition of f of x, sorry, that will give us the y values, it's x squared plus 3 if the x value we have is less than or equal to -2, or it's 2x minus 8 if the x value is greater than -2. So the first thing you need to decide, this is super important, this is where some students run into trouble, but the very first thing you have to decide for the given x value which definition you're going to use. Then only use that one. Okay. So you make your decision first off based on the x value that you have, and once you've made it, don't look at the other one. Okay. So that first one we have, f of -5. So we have to decide, does -5 fit this criteria or this criteria? Is -5 less than or equal to -2, or is it greater than -2? Right? Since -5 is less than or equal to -2, we will use the top definition. Okay? Because when we compare the value we're given to which chunk, right, -5 falls into that top chunk, so we use that top definition. So we ignore the bottom one. So for x is less than or equal to -2, we use the definition, okay, whatever you give me, I'm going to square and then add 3. So -5's quantity squared is 25 plus 3 is 28. Okay, and then you stop. That's it. What about the next one? F of 6. Where does 6 fall? Into the top category or the bottom category? Is 6 less than or equal to -2, or is 6 greater than -2? Exactly, right? It's greater than -2, so we use the bottom definition, and only that. So we'll go ahead and cover up the top one so I don't feel tempted by it. So 2 times 6 minus 8. Oh, extra parenthesis there. So 2 times 6 is 12, minus 8 is 4, and that's it. Okay. F of 0. Where does 0 fall? Less than or equal to -2 or greater than -2? Right, 0 is greater than -2, so we'll use the bottom definition. Again, I'll cover up the top one so it doesn't tempt me. So bottom says whatever you give me, I'm going to multiply by 2, subtract 8. 2 times 0 is 0, minus 8, -8. Last one, f of -2. Where does -2 fall? Right? Exactly, on the top one. That has the or equal to -2, right? So we'll use that top definition, cover up the bottom one. So top says whatever you give me, I square, and then I add 3. So -2 squared is positive 4. Plus 3. Be careful, I'm going to go ahead and I'm writing while I'm talking. Be careful if you're using a scientific calculator to do your arithmetic for you. Because if you type in -2 and then use your little x squared button on your calculator and then equals, what your calculator will do is it will do this. Okay, so on a calculator, this set of keystrokes, so right there's a little change sign key, whatever, and then 2, and then the squared button, and then equals. This is going to spit out -4, which is not what I mean when I write this. Okay, so if my input is -2, and what we're doing is squaring all of that input, hopefully that's still on the screen up here at the very, very tip top. Okay, I'm squaring the entire number -2. That means -2 times -2, the two negative signs have to cancel to give you a +4. Okay. What the scientific calculators do, it's correct, right? It's doing an order of operations first. So it's doing this set of keystrokes. So it's going to do your exponents first. It's going to square the 2, and then it's going to apply this -1. It's almost like -1 times 2 squared, so the exponent comes before the multiplication. You can absolutely get around it, or you could do it in your head, right? If you want to get around it, it's like, I don't want it, Angela. Okay, then you have to use the parentheses. So most calculators have parentheses these days, so find them. Wrap your -2 in them, and then do your x squared button and your equals. And that should give you the correct +4 value. Okay? All right, be careful with that. Okay, on to My Math Lab to do the 7-2 homework, and then I'll see you in 7-3.